Okay, today we're going to look at some special linear functions. These are all piecewise functions. Their absolute value function, the step function, and the greatest integer function. So we're going to start with the absolute value function. Okay, so here's our absolute value function. It looks like a V when it's on a coordinate plane. And this says the f of x is equal to the absolute value of x. It's an even function because it's symmetrical about the y-axis. Any function that is symmetrical about the y-axis is called an even function. The domain is going to be all real numbers, meaning we can put any number we want in for x. Negative numbers, 0, positive numbers. That little funny R looking thing, it stands for all real numbers. Our range is going to be from 0, including 0, up to infinity. That means all the answers to an absolute value problem must be 0 and greater, or 0 and positive numbers, all the positive numbers. It is also a piecewise function. Okay, so here is our absolute value function written algebraically. And when it's written algebraically, it's written in two pieces because the V has two pieces. So in our first one, we're going to look at the values being the negative of x for all the values where x is less than or equal to 0. So let's say if we take the point -1, we're going to take negative of -1, which is going to give us +1, as indicated by the blue dot on the graph. Then if we take -4, the negative of -4 is going to be +4. We have 2 points, and we can go ahead and connect those with a line. Now we're going to do those values that are greater than 0. For those values greater than 0, for x greater than 0, you're just going to use x. So when we talk about 2, we're going to get 2. And when we use 4, we're going to get 4. Then we connect those 2 points with a line. So I just want to clarify a little bit. If we pick a point like -1 for x, we're taking the negative of -1, which would give us +1. And if we, for our f of x. And if we took -4, then we're taking the negative of -4, which would be +4. Okay, so here is a regular piecewise function. This one happens to have 3 pieces. So we have to, the domain comes in 3 parts. X is less than or equal to 2, x is between 2 or less than or equal to 3, and x is greater than 3. So let's look at our first part. We're going to start with the endpoint, so we're going to pick 2, and we're going to say 2 plus 1 is 3. So at the point 2, we get 3 as a y value. So we graph that point 2, 3, and then we pick another point, let's say 0. We plug 0 in there because 0 is less than 2. We go 0 plus 1 is 1, and so we're going to graph that point as well. Then connecting those 2 points with a line, we're going to get that graph. As the values get smaller, they're going to go to negative values, and so we would put like a -4 in. -4 plus 1 would give me -3. So we go over to -4 and down to -3. For our second set, the numbers between 2 and 3, notice there's no equal sign for the 2. But we're still going to use that point. So we're going to plug 2 in, and we're going to get -2 times 2, which gives us -4. But when we record that point, we're going to put an empty circle because it does not include that point. That's because if we drew a vertical line at 2, we want to be sure we only intersect the graph one time, or it will not be a function. Then if we put the other side, 3, into the equation expression, we get -2 times 3 is -6. But that point can be a solid point because it has an equal sign under it. And then we connect those values together. Finally, we get to the last one, and we have x minus 1 if x is greater than 3. So once again, we use 3, but this time it will be an empty circle once again because there is no equal sign there. and 3 minus 1 is 2. So we have an empty circle there. And then we could pick another point like 4, and 4 minus 1 would be 3. And then we would go ahead and graph that line. So in this case, we have 3 pieces. So let's take a look. Let's take a look at the greatest integer function. This is the greatest integer function graphically. It is a step function. I guess you can see why it would be called a step function. It's also a piecewise function because it comes in pieces. Algebraically, it's written as f of x is equal to, and then it's in a double set of brackets, x. So let's try some recordings here. Let's try some examples here. We have the greatest integer of 3.5. So let's look at what the graph would look like. We want to start off with the 3.5 and where it's located on a number line. It is located between the two integers 3 and 4. 3.5 is located about right here. So what we want to do is we want to start on the left-hand side of the graph and go past, keep going till we get to the orange dot, and then we say, what is the greatest integer that we passed going to the orange dot? And that integer would be 3. So the greatest integer of 3.5 is 3. Let's look at another example. The greatest integer of negative 2.3. Now here, the number line, the values that it's between are negative 2. And, nope, not 0, because that's what people think, because they think that 2.3 is higher, but it's not. Negative 2.3 is actually lower, so it's between negative 2 and negative 3. It's located about there. Once again, we're asking ourselves, going from the negative side, our value continues till we get to the point, orange point, and what is the greatest integer that we pass getting to that value, and that would be negative 3. Let's look at negative 7.5. I'm sorry, negative 0.75. The graph of this would be located between 0 and positive 1, approximately there. And we ask ourselves, what is the greatest integer we pass coming from the left, going to this value, and that value would be 0. So we would have negative 3 for the second one, 0 for the third one. Well, what happens when we take the greatest integer of an integer? Well, it's just the integer itself. Now let's look at a step function. Here I have 2 step functions. The black one would be called a ceiling function because the line after 0 is above the x-axis. So it would be called a ceiling function. It follows the same pattern all the way up. Another type of function would be a floor function. That would be the blue line. The blue line is called a floor function because the first graph at 0 starts on the x-axis, hence the floor. This is also a special type of piecewise function. You will not be asked to know the floor and the ceiling function, but I wanted to make you aware of them. So in case it refers to that on ACT or some other standardized test, you would know what a floor and a ceiling function was. Algebraically, a step function, you would list out all the pieces from negative infinity to positive infinity. But that, of course, would be very difficult to do. So usually when you have a step function, instead of writing it out like we did here with the pieces, you would write it as a modified greatest integer function. Again, you will not be asked to do this, as this is part of a college algebra curriculum. What you will be asked to do, however, is if you can compare and contrast the various piecewise functions. Do you know, is the greatest integer a piecewise function? Is the greatest integer a step function? Are all step functions greatest integer functions? So these are the types of questions you'll be exploring in class. See you tomorrow.